Hello everyone, welcome to today's webinar. My name is Barry de Graaf and I am Channel Evangelist at Zinnocor. This is the first webinar in a series about email security. In these webinars we will provide practical how-to information and best practices to help you maximize Zimbra email security. We will cover things like SPF, DKIM, DMARC, TLS, DNSSEC, DANE and more to ensure maximum email integrity and confidentiality. During this webinar, you can ask questions via the Q&A panel, and I will try and answer most of them on the fly. Some questions we may also discuss live during the webinar. Today's webinar is recorded and will be published on our YouTube channel, where you can find it for future reference. This webinar is a collaboration between Zimbra and Randy Leiker from Skyway Networks. Randy is an expert in email security, and he will provide you with all the best practices and insights you need to get started on maximizing your security. So without further ado, I would like to give the virtual microphone to Randy.
All right, thank you, Barry. Appreciate that introduction. Well, thank you, everyone, for joining us today for the first episode in the new webinar series that is all about email security. Today, we will specifically be talking about two topics, SPF and DKIM. So as a brief introduction, I am the president and CEO of Skyway Networks. Skyway Networks is an email service provider specializing in Zimbra hosting and consulting. We also provide a variety of cloud hosting services, including software development. I've been working in the IT industry for 26 years, and of that time, 23 of those years with Skyway Networks. And I have a long history of Zimbra dating back to version 5.0, so I've had the privilege of seeing it evolve from that time. As an overview of today's topics, I will be discussing real-world hands-on approaches that you can immediately use by the end of this webinar for deploying both SPF and DKIM email authentication. This includes a discussion of what SPF and DKIM do, how to correctly set them up, and why you should use them. Even if you've already deployed SPF or DKIM, there is something here for everyone, as I'm going to discuss a number of real-world best practices along with common deployment pitfalls to avoid that are not always obvious, even for those that have already been using one or both of these standards for some period of time. If you've tried learning about SPF or DKIM from various online sources in the past, but find that the information seems contradictory or confusing, this webinar is tailor-made just for you. Following each topic, I will pause and take your questions and try my best to answer those for you. This webinar is being recorded, as Barry mentioned, and will be posted for later replay on the Zimbra YouTube channel at the URL you see on the slide. So this is the first episode in webinar series about using modern email authentication and encryption to protect your users from a range of common threats. Some of these threats include phishing, eavesdropping, information leakage, man-in-the-middle attacks, and security downgrade attacks. As you can see on screen, there is a comprehensive list of important security standards that will be covered in upcoming episodes of this webinar series, and I hope that you can join us for all of them, as it should be educational and well worth your time to attend. In each webinar, I will refer to outside documentation and tools where relevant, but the goal is to get you information that you can immediately use to get started with each security standard within a short time frame, without needing to spend days or weeks reading documentation. So with that said, let's go ahead and dive into our very first topic, which is SPF. So in the 1970s, there were various approaches in use for sending email on ARPANET, which was the internet's predecessor. But by 1981, these efforts were all combined and became known as a new standard called Simple Mail Transfer Protocol, or SMTP, as it's more commonly known. So back then, the concept of email abuse, much less spam, was unheard of. And consequently, SMTP was designed with no concern for security. It was not long before internet users discovered how trivially easy it was to forge the from address of their messages with any email address, including email addresses of others or fake addresses they had no authorization to use. So despite multiple revisions to the SMTP standard since 1981, these weaknesses still live on today. So Sender Policy Framework, or SPF for short, was first proposed as a standard back in 2004 in an attempt to begin fixing this ability to hijack email addresses of others. Its purpose is simply to provide a domain name owner with a means to specify the IP addresses on the internet allowed to send email for a given domain name. So the best way to explain how to use SPF is by example. Meet Jill. She runs a successful consulting company and owns the domain name Zimbra.tech. Her company sends email from a Zimbra server, a web server, and a cloud service provider called emailthem.corp that sends newsletters to her clients. Each of these sources send messages from email addresses that all end with @Zimbra.tech. For example, Jill at Zimbra.tech. Jill has seen instances in the past where the email addresses for other companies have been hijacked to send out spam, malware, or connect phishing attacks, and she wants to avoid the same type of harm to her company's reputation by preventing her domain name, Zimbra.tech, from being abused too. So as a first step, Jill's decided to set up SPF. Jill begins by collecting the IP addresses of all of the servers that send messages using a Zimbra.tech email address. She has the ability to make changes to the DNS records for Zimbra.tech using a control panel from her hosting company. Using this control panel, she creates a new DNS text record with a host name of Zimbra.tech that starts with the content v equals SPF1. All SPF records must always start with v equals SPF1, as this identifies that this is an SPF record and that it is using version 1, the only SPF version currently supported on the internet. Jill continues creating her SPF record by listing the IP addresses she collected earlier for all of her Zimbra, for her Zimbra email server, the web server, and her newsletter mailing service. Each of these IP addresses are prefixed with IP4 keyword. Since Jill's newsletter vendor is also using Internet Protocol version 6 addresses to send her newsletters, Jill uses the IP6 keyword to add this address too. Since Jill is just getting started with SPF, to be careful, she ends her SPF record with ~all. The tilde means soft fail, and the all keyword means all IP addresses on the internet. Jill's SPF policy now effectively says, when a recipient receives a message from a Zimbra.tech email address, if the email did not originate from an IP address in Jill's SPF record, the email should be considered possible spam. But it is still up to the recipient's email server if they want to quarantine it in a spam folder or allow it to pass through to the recipient's inbox. Bear in mind that every SPF record must always end with the all keyword. So Jill notices in her control panel that she has two existing DNS records set up. She has a DNS MX record and a DNS-A record. The MX record informs senders on the internet to deliver inbound email to her Zimbra server named mail.zimbra.tech, and the DNS-A record enables senders to determine the IP address for her Zimbra server. Since Jill's company both receives and sends email from the same Zimbra server, she realizes she can simplify the SPF record she just created. So Jill returns to her SPF record and deletes the IP address for her Zimbra server. In its place, she adds the keyword MX. Now, when a recipient receives email from Jill's company, they will automatically look up Jill's DNS MX record, get the mail.zimbra.tech name, then determine the IP address for mail.zimbra.tech, which is 64.200.180.2. This IP address will now be considered part of Jill's SPF policy. If in the future Jill opts to add multiple DNS MX records, then the IP addresses for each of those MX records will still be merged into her SPF record automatically, with no changes necessary to Jill's SPF record. So this can be a real time-saving shortcut. Now, what if Jill had her Zimbra server set up like this, where inbound email is sent first to an anti-spam appliance for filtering, then the remaining clean messages are delivered to her Zimbra server. Any messages that Jill's company sends go directly from her Zimbra server back to the internet. In this example, Jill's DNS records would look like this, where her DNS MX record now informs the internet to deliver all inbound email to her anti-spam appliance at spamtrap.zimbra.tech and not directly to her Zimbra server. This is a common setup for many Zimbra servers, and in this instance, Jill should not use the MX keyword in her SPF record as we saw earlier. This is because her anti-spam appliance only receives the email but does not send it. And since only IP addresses that send email need to be listed in Jill's SPF record, she only needs to list her Zimbra server's IP address of 64.200.180.2. As added clarification, if Jill configures her anti-spam appliance to refuse delivery of spam messages, thereby creating bounce messages every time a spammer sends her an email, The MX keyword should still not be listed in their SPF record, since the messages are being bounced and not accepted for delivery. So returning back to our original example, Jill continues to simplify her SPF record and now replaces her web server's IP address of 64.200.180.3 with a special A keyword. Similar to how the MX keyword functions inside of an SPF record, the A keyword informs a recipient of email from Jill's company that they should look up her DNSA record and consider its IP address to be part of Jill's SPF policy. To be clear, this refers only to the DNSA record for Zimbra.tech and not to any other DNSA records that Jill has set up. So for example, Jill's DNSA record for blog.zimbra.tech wouldn't be excluded. But Jill's website for blog.zimbra.tech also sends email from an address of blog@zimbra.tech within the IP address 64.200.180.4. So Jill earlier listed this IP in her SPF record. Jill can still use the same A keyword here too by simplifying her SPF record with a:blog.zimbra.tech. In doing so, it pulls the IP address in for blog.zimbra.tech and makes that part of her SPF record. So after a few weeks of using her new SPF record, Jill learns that some of her newsletters sent by her vendor, emailthem.corp, are going into her client spam folders. She determines that the vendor is using some IP addresses that Jill was unaware of and did not include in her SPF record. To fix this, Jill's vendor suggests that she remove the vendor's IPs from her SPF record and in its place use include:/SPF.emailthem.corp. Jill's vendor has already published their own SPF record that lists all of the IPs the vendor uses for sending email for their clients. So on the vendor's end, this is simply a DNS text record they have set on the slide. Once Jill makes this modification to her SPF record, it effectively tests her vendor's listed IP address first, in addition to the IPs listed in Jill's own SPF record, all in just one step. Going forward, anytime Jill's vendor updates their SPF record, the update is automatically applied within Jill's SPF record too, without any further action required on Jill's part. So Jill later decides that her SPF record is working well, and she wants to make one minor modification by changing the tilde-all to -all. The hyphen means fail. This informs anyone who receives a message from a Zimbra.tech email address that the message must have originated from one of the IP addresses in Jill's SPF record. If it does not, then recipients are advised to consider the email spam. However, even with this more restrictive setting change, it still remains at the discretion of the recipient's email server if Jill's SPF policy is ignored, causing the suspect email to be delivered to a recipient's inbox anyway. To close this potential gap, a security standard called DMARC will be introduced in the next episode in this webinar series, and it will provide Jill with even more control over how email that fails her SPF policy is handled by a recipient's mail server. So let's wrap up our discussion of SPF by reviewing some best practices. You may have only one SPF record per domain name or per subdomain. If your email address were you@zimbra.tech, you would publish one SPF record only for Zimbra.tech. If you also had the email address of you@research.zimbra.tech, then you would again create only one SPF record for research.zimbra.tech. If you publish multiple SPF records for a given domain name or subdomain, you will get unpredictable results, but more than likely your SPF records will be ignored. Before publishing an SPF record on your DNS server, the first essential step is to compile a list of all public IPs that send email using your domain name. Never list any private IP addresses in your SPF record, such as the IP addresses that are accessible only on your internal LAN network. In some cases, this task can be challenging, as you may find that email is originating from unexpected sources. To make this task easier, there is a reporting feature and another security standard called DMARC that can help you compile these IP addresses. Again, I will introduce you to DMARC in the next episode of this webinar series, but in the meantime, here is the minimum you will need to enable DMARC reporting. If your email address ends with @zimbra.tech, then create a new DNS text record with the hostname of _dmarc.zimbra.tech. For the content of this DNS record, enter v equals dmarc1, semicolon p equals none, semicolon rua equals mail2, colon u at zimbra.tech, semicolon. You will, of course, need to substitute zimbra.tech with your actual domain name that sends email. However, ensure that the email address you list in this DMARC record is using the same domain as your DMARC's hostname. In other words, you at zimbra.tech will work fine in this example, but you at anotherdomain.com will not. Within about 24 hours, you should begin receiving reports from some of the largest email providers that are receiving your email, showing you a list of IP addresses that are sending email using your domain name. These reports will typically be in a zip or tar-gzip file format with a text file inside formatted in XML. You can use freely available tools like 7-zip for decompressing these files and Notepad++ for formatting the XML files for easier readability. Be aware that these reports might also include IP addresses of people abusing your domain name for spamming too. So of course, be sure to confirm that each IP in the reports is actually one of your legitimate servers, for including those IPs in your SPF record. So when you do publish your SPF record, if you are still uncertain if you have a complete list of all IPs that send email using your domain name, end your SPF record with a ~all keyword instead of the stricter -all, just as I demonstrated in the earlier example with Jill and the zimbra.tech domain name. Once you feel confident that your SPF record is complete, your goal is to use -all to properly enforce the protection that SPF offers. Avoid using +all or $all, as this is similar to having no SPF record at all. If you have SPF records are less strict with the all keywords, such as ~all or $all, then the last all keyword in your SPF record has the final say. This enables you to enforce a stricter SPF policy even if the other SPF records you are including are less strict. And finally, it's important to protect your non-email sending domains with SPF policies too. For domains or subdomains that will never send email, publish an SPF policy of v equals SPF1 -all. This will make it difficult for the bad guys to hijack your domains and subdomains for sending spam, phishing, or malware campaigns. The bad guys can easily discover your domain names from the public who is database and subdomains using automated scans of your DNS records. Another tip is to avoid listing large blocks of IP addresses in your SPF record, such as every IP address in your network. As an example, if you were to use IP4:209.136.72.0 in your SPF record, it essentially allows 254 different IP addresses to send email. While this may seem convenient or safe to avoid missing an email sender's IP address, it also gives unauthorized senders many IPs to choose from for hiding illegitimate email sent using your domain name, effectively creating holes in your security policy. And beware of the SPF lookup and length limits. As demonstrated in the earlier examples, you may use special keywords like a, mx, or include in your SPF record. Each of these keywords requires one or more DNS lookups that the recipient of your email must do to resolve each keyword to an IP address. To avoid potential abuse, the SPF standard imposes a limit of 10 DNS lookups. If the 10 lookup limit is exceeded, then the remainder of your SPF record will be ignored by recipients. So let's look at two examples to illustrate this concept. In the first example, we have an SPF record with a total of 3 DNS lookups. The first lookup retrieves the SPF record for the included _SPF.emailthem.corp. The second lookup is to determine the IP address for our DNSA record for zimbra.tech. And the third lookup is to determine the MX record and its IP address for mail.zimbra.tech. This is a valid SPF record and should work fine. In the second example, we have an SPF record with a total of 11 lookups. This violates, of course, the 10 lookup limit. So this time around, the include for _SPF.emailthem.corp is more complicated. Not only does the include have its own DNSA and MX lookups, but it also has another nested include within it for underscore spf.anothervendor.com. This is more common than you might expect, especially among vendors that you might use for sending outside email. At 11 lookups in total, this SPF record is not valid, and at least some portion, or perhaps all of it, is guaranteed to be ignored by your email recipients. To fix this, the owner of the SPF record could replace some of the A, MX, or include keywords with IP addresses instead, thereby reducing the number of DNS lookups required. This technique is called flattening an SPF record and is commonly used. So, and finally, beware of that the entire SPF record from beginning to end cannot exceed 255 characters in length. So if you are using all IP addresses in your SPF record, again, the same limit applies that cannot exceed 255 characters. If you exceed this limit, your SPF record will again be likely ignored by email recipients. This is less common of an issue, but if you should encounter it, a way to deal with it is to break your SPF record into multiple parts by using the include keyword. This allows you, for example, to use each include of 255 characters each. So if you had two includes, 510 characters in total. So I'm going to pause here to answer any SPF questions you have before we get into our next topic, which is DKIM.
There's a number of questions.
Right.
Let me start with this one. It comes from Mark, and he's asking, what does Zimbra do by default when receiving an email from an IP address not listed in the SPF record, when the sender's SPF record is ending with the -o?
So by default, Zimbra is going to is not going to actually look at the SPF record on its own unless you've specifically configured it to do so. And again, this is typically something that would be served by, say, Spam Assassin. Spam Assassin is really what is responsible for doing these checks for SPF and DKIM and the like. So for example, if your Zimbra server is just simply sending email out to the internet and you've not explicitly configured Spam Assassin to check outgoing email, then it's basically not looking at the SPF record at all.
All right, let's see if we have anything else. Oh, everything else has been answered already, so good to go.
Oh, okay. All right. So let's look at what DKIM is and why we need it. So in the early 2000s, Yahoo and Cisco were working on independent approaches to tackle more shortcomings in SMTP. In 2004, at about the same time frame as the SPF standard was first proposed by another early trailblazer, Yahoo and Cisco agreed to combine their efforts into a single standard called Domain Keys Identified Mail, better known as DKIM for short. So before DKIM, there was no practical option that could be used on a global-sized network like the internet for a recipient's email server to authenticate if a message actually originated from a sender's email server. The same problem applied to verifying the integrity of a sender's email message too, in order to check if it had been altered by an unauthorized third party in transit. So these are the problems that DKIM was created to solve. So again, let us look at continue our earlier example of Jill and setting up her consulting company's domain name, Zimbra.tech, for use with DKIM. So Jill wants to start with setting up DKIM for her Zimbra server, and she will need to accomplish two steps. In the first step, she needs to generate a pair of encryption keys, and in the second step, she will publish one of those two keys as a DNS text record. Let us take a look at how those two steps work in more detail. So Jill has a Windows PC, so she opens the freely available PuTTY app, and she connects to her Zimbra server using SSH. This now enables her to run commands from her server's command line. Since her Zimbra server is running Ubuntu, she first switches to the Zimbra user by running the command sudo su-zimbra. If Jill had been using CentOS, a derivative of Red Hat Linux, she would have instead used su-zimbra to accomplish the same thing. Next, Jill takes advantage of a helpful utility built into Zimbra to generate the encryption key pair she needs for securing her Zimbra.tech email with DKIM. So she runs the command /opt/zimbra/libexec/zm DKIM key util -a-d zimbra.tech. The -a means that she is adding a new domain for use with DKIM, and the -d specifies the domain name to be set up. So after running this command, Zimbra automatically accomplishes a few different things. A new matching private and public encryption key are generated and stored inside of Zimbra's LDAP server. And DKIM is now enabled for all emails sent from Zimbra.tech domain name going forward. So after running this command, Jill sees on-screen output that looks just like what you see on the slide. And there are two key bits of information shown in the output that Jill will need for completing the second and final step that involves creating a DNS text record. So Jill opens the same hosting control panel she used earlier for setting up the DNS text record for SPF, and she now adds a new DNS text record. Jill examines the Zimbra output from the command she ran just a moment ago, and she sees what is called a DKIM selector, as highlighted in the middle of the slide. She carefully copies and pastes the entire DKIM selector and adds .zimbra.tech to the end of it to create the hostname for her new DNS text record. Next, Jill copies the public encryption key, as highlighted again in the middle of the slide. Zimbra automatically splits this public key into a couple of shorter strings of text, separated by double quote marks for compatibility with DNS servers like Bind that require this format. But Jill's control panel allows her to add the entire public key as one complete string, so she carefully removes the quote marks and spaces separating the public key and pastes it into her DNS text record as one long string, as shown in the bottom of the slide. This public key is normally much longer, but has been truncated for illustration purposes to fit again within the slide. Jill has now completed all of the setup steps required to use DKIM on her email server. If Jill had been using a Bind DNS server, she would have needed to copy and paste the DKIM public key identically as it was output from Zimbra into a DNS text record, and enclose the public key within parentheses, highlighted in red on the slide. Bind requires that each quoted string of text does not exceed 255 characters. So this is why Zimbra splits the DKIM public key into multiple quoted strings. Again, the public key is normally much longer, but has been truncated to fit in the slide. So now that Jill's Zimbra server is fully set up with DKIM, she now wants to deploy DKIM for her newsletter mailing service and also on her web server. While these steps are not required, it is highly recommended that Jill secures all sources that send email with DKIM. The reasons for this recommendation will be explained in greater detail in the next episode of this webinar series, where the DMARC security standard will be discussed. But for now, let us assume that setting up DKIM on all of Jill's servers that send email is in her best interest. To make that happen, Jill first contacts her newsletter vendor, emailthem.corp, and the vendor provides her with instructions on how to generate a DKIM selector and encryption key pair using the vendor's website. You may notice that this DKIM selector looks very different from the selector that we saw generated on Jill's Zimbra server earlier. The selector can in fact be any alphanumeric text string and simply serves as a kind of unique identifier for the DKIM key pair that Jill's vendor has created. We will see a little bit later in the webinar how the selector is used when Jill's company is sending email. So using her hosting control panel, Jill next creates another new DNS text record. This time she sets the host name to the DKIM selector provided by her vendor, then appends the text ._domain key .zimbra.tech to the end of it. The ._domain key portion is required for all DKIM records. Jill now carefully copies and pastes the complete public key provided by her vendor into her DNS text record's content, similar to what we saw with the DNS text record that Jill set up for her DKIM on her Zimbra server. This DNS text record also begins with v = DKIM1, indicating that this is a DKIM DNS record and that it is for version 1, the only version of DKIM currently supported on the internet. This is followed by the text RSA, indicating which algorithm was used to generate the public key. And finally, the p = text contains the public key itself. If Jill were using a Bind DNS server, just as we saw earlier, Jill would again need to break this public key up into quoted strings of no more than 255 characters each. With this new DNS text record now complete, Jill has everything needed to start protecting her company's newsletter with DKIM. So Jill is ready to finish things up by setting up DKIM for her web server, but she encounters a problem. Her web server that sends Zimbra.tech email has no DKIM support available. Jill now has to make a decision. Should she continue to send email from her websites as is without DKIM, or should she instead configure her websites to relay all their outbound email through her Zimbra server? Since Jill has plans to set up another security standard later called DMARC, she realizes the importance of using DKIM everywhere possible. So she opts to configure her websites to send all their outbound email through the Zimbra server. This in turn allows her Zimbra server to automatically sign those messages generated by her websites with DKIM encryption keys that she has set up in the earlier. So to accomplish this, Jill creates a new email account on her Zimbra server dedicated to her websites called website@zimbra.tech. She then configures her websites to send all email via her Zimbra server along with her username and password. Be aware that now that Jill's web server is now no longer sending email directly to recipients, but rather is relaying all outbound email through her Zimbra server, this now means that Jill can remove her web server's IP address from her SPF record, as we saw earlier. So let's look at how DKIM actually goes about protecting your email. When you send a message from your computer or mobile device, no DKIM protection is applied at that point. But once your message reaches your mail server, this is where the DKIM signing magic happens. It breaks down into 3 general steps. You may recall that when Jill set up DKIM on each of her servers, I mentioned that both a private and a public key are generated. That is part of the key pair. Step 1 uses this private key to create a digital signature known as a hash of just the body of your email message. The hash will basically be a big alphanumeric string. In step 2, the Zimbra server selects certain header fields from your email, like the date, from, and the to fields, combines them with the body of your email message, and again uses your private DKIM key to create another hash. And finally, in step 3, both of these hashes are embedded into your email, then the email is delivered as normal to the recipient's mail server. When the recipient's mail server receives your email, they will find a DKIM signature embedded that looks just like what you see on the slide. The recipient uses this information to validate your email using DKIM. So what exactly does this DKIM signature do? To save time, let's discuss only the essential part of how DKIM validates that a message originated from the sender's legitimate mail server, along with ensuring that email was not tampered with in transit. The recipient's mail server is going to look at the S equals field, and it sees a selector name in this example that's called example. It then looks at the D equals field and sees that this is set to Zimbra.tech. So it puts these together and it does a lookup for the DNS text record called example._domain key.zimbra.tech. And this provides the recipient with the sender's public DKIM key. The recipient then uses this key to create their own hashes of the email message, just like the sender did. Next, the recipient compares the hashes that they came up with against the hashes the sender embedded in the DKIM signature, specifically the hashes in the BH equals and the B equals fields. If the hashes match, then the recipient knows the email did in fact originate from the sender's legitimate mail server, and that the message integrity can be trusted, meaning it was not tampered with or altered in any way while in transit. But if the hashes do not match, then the recipient knows the email is likely a forgery or was in some way altered before reaching the recipient, thereby making the email suspect. So let's look at some DKIM best practices. Your goal should be to set up DKIM on every server that sends email for your domain names or subdomains. In the next episode in this webinar series, I will explain in more detail why this is important as it relates to the DMARC security standard. But for any servers that send email and do not support DKIM, strongly consider configuring those servers to relay their outbound email through a DKIM-capable server like Zimbra, so that all messages can be DKIM signed. If you configure your non-DKIM-capable servers to relay their email through another DKIM-capable server, then those non-DKIM capable servers should be removed from your SPF record because, again, at that point, they are not sending email directly to the internet. This is, and so consider creating a recurring scheduled process that changes your DKIM keys periodically on your email sending servers. This is called key rotation, and should an attacker ever be able to obtain one of your private keys by theft or by brute force guessing, routinely rotating your keys will invalidate an attacker's ability to send out forged emails that impersonate your users or that abuse your domain or subdomain's online reputation. Key rotation basically involves creating a new DKIM key pair on each email sending server, adding the new public key to a DNS text record, then removing the old DKIM key pair from your email and DNS servers. This is not difficult, but it can be somewhat tedious to do manually, so it is an ideal candidate to automate with a scripted process where possible. When you do rotate your keys, try to create a new DKIM selector name each time. Should you need to troubleshoot why a message failed to validate with DKIM, it makes it so much easier to tell if an email was using your old or your new DKIM key pair based on the selector name in the email's DKIM signature. If the organizations are very security sensitive, may opt to rotate their DKIM keys as early as once every few weeks, while other organizations may never rotate their keys. You should ideally aim for something in the middle of these two extremes based on your organization's tolerance for risk. On the servers that you set up DKIM for, bear in mind that your DKIM private key must always remain a secret. When you make backups containing your DKIM key pair, ensure that the backups are preferably encrypted and stored in a secure location. If your private DKIM key should ever fall into the wrong hands, then your only choice will be to revoke the affected DKIM key pair and reissue a new one. This process of revoking a key pair is the same process described in the previous slide for rotating your DKIM keys. And finally, never share your DKIM key pairs or selector names between multiple servers. While it is technically possible to do this, and it may seem to be a time saver since only one DNS text record would need to be maintained for DKIM, this is in fact a very bad idea. If any of the servers sharing the same DKIM keys or selector were compromised for any reason, such as hacking or accidental information leakage, then you would be forced to do an immediate key rotation on all the affected servers simultaneously, since the private key is no longer secret. By creating a unique key pair, a DKIM key pair, and selector per server, it not only limits and isolates any fallout damage from a breach, but makes it easier to troubleshoot as each email sending server can be uniquely identified by its DKIM selector. So I'm going to pause here again to answer any DKIM questions you have before we do wrap up of this webinar with the key takeaways.
Oh, there are many questions. There's one question, I'm not really sure if I understand it correctly, so I'm just going to ask it. What is your stance on DKIM oversigning? What headers do you think should be signed?
Well, it's going to depend on the situation. If you are talking about your Zimbra server, then Zimbra is going to make that determination for you. So again, it's going to be things like the from, the to, the date, the message ID, the MIME type of the message. Those are generally the headers that Zimbra specifically focuses on. There might be a way to override that if you go tinkering in Zimbra, but generally I think you're going to be okay with that set of headers. Now on other servers that are not Zimbra, that may be entirely at your discretion what headers you specifically want to sign with DKIM. In that case, I would probably focus on those same essential headers that Zimbra does because they are pretty important. If you wanted to add other headers, for example, the subject or the return path from field, you certainly could. The fine line you walk here is that if you get carried away with this and you start signing headers with DKIM that may change as an email is forwarded from mail server to mail server, for example, as a mailing list, then your DKIM signature is invalid. So again, you should focus on signing headers specifically that are less likely or unlikely to ever change as it passes from mail server to mail server.
All right. One other question, as someone asked, and I was typing, so I didn't know if we covered that or not. Did we cover the underscore domain key policy records for DKIM in the slides just yet, or no?
I did. Yeah. So again, I'll see if I can quickly find the slide for you. Bear with me 1 second here. Yeah, so here we go. So again, looking back at this example, remember that the selector name always goes first, followed by a ._domain key that must be there no matter what, followed by your domain name. That is the syntax that you must use for every DKIM DNS record. Again, that _domain key part is very critical that that is there.
Okay, one more question. Are there any known weaknesses in DKIM, and how do you think about changing your DKIM keys regularly?
Well, there are the main weaknesses that pertain to DKIM, again, one of which I mentioned is if your private key is compromised for any reason, that's one potential weakness. Another potential weakness is if the DKIM key that was created or key pairs created is too weak. So when you're generating encryption keys, there's the concept of the number of bits that are used. The idea is the more bits in an encryption key, the more difficult it is to break an encryption key. So early on, when DKIM was first getting started, it was pretty common to see DKIM keys out there that were created with 1024 bits. By today's standards, those are pretty weak encryption keys. Most of the encryption keys, in fact, really all encryption keys you should be using these days, use at least 2048 bits. So this is many, many times exponentially more difficult to crack than a 1024-bit key. So again, protect your private key, just as I mentioned earlier in the slides. And 2, make sure that your DKIM keys are always 2048 bits or more. But again, don't get carried away with that. Don't go to something crazy like 4,000 or 6,000 bits, because then it actually uses a lot more CPU resources on both servers to, again, do that encryption and decryption. And nobody appreciates having their mail slowed down.
That is true. The previous question about the selector records has been more clarified on the chat. It's actually quite a complex question, so I'm not sure if we can cover that with the time that we have. The question is about policy records, not so much selector records. And he says he's talking about is and that sort of thing. I'm not sure if you can read the question and then take it from there or not. Can you see the Q&A panel?
I can try.
It's the last question that is in the list there.
I am getting that open real quickly here for us.
And if you can't find it, I'm just going to read it out loud. But
I see it. I'm just quickly reading it here. I probably need to answer that one offline. So I'd be happy to follow up. My contact information will be on another slide. So Quentin, I would be happy to have you reach out to me and I'll follow up with you on that one.
Yeah, we may also just, if it's interesting, we can just take it on the next webinar.
Sure, that too.
All right. I think that's enough for the questions for now.
Okay. All right, so to wrap things up, here are some key takeaways to keep in mind. Deploy SPF and DKIM for every server that sends email for your domain names or subdomains. Similarly, deploy SPF records to protect your non-email sending domains and subdomains. This is commonly overlooked and ripe for abuse. Check for SPF and DKIM DNS records carefully. And check your SPF and DKIM records carefully, I should say, and make sure that you use online validation tools to ensure they are correct. This confirms your SPF and DKIM records are actually usable by your recipient's mail servers. And watch out for the SPF limit of 10 DNS lookups. This occurs more frequently than you might expect. Copy and paste your public keys for DKIM public keys into your DNS text records with care. Omitting or altering just one character in a public key will break your entire DKIM record. And also avoid complacency in creating or not creating a process to do key rotation for your DKIM key pairs. The reasoning is basically the same as why we have SSL certificates for websites that have expiration dates. If they are never rotated, then again, it makes it that much easier for an attacker to have an unlimited amount of time to break your DKIM keys. So thank you so much for attending today's webinar. I hope you found it educational, and I'm going to leave you with a couple of links to resources you can use for testing your SPF and DKIM records. If you would like to reach out to me directly with additional questions or feedback, my contact information is included.
All right, thank you all very much. As again, this entire recording will be ending up on our YouTube channel where you can see it for future reference. We'll also send out the slides that we have just shown you on the screen via email later. And we hope to see you on the next webinar, which was again about, Randy, can you help me? What was the next
Yep,
about?
the next webinar is all about DMARC and BIMI actually. So as a brief preview of that, DMARC is again a way for you to enforce your SPF and DKIM records, basically telling a recipient that if your SPF or DKIM record failed to validate, here is a specific action that they should take. So it's a very important part of SPF and DKIM. The three basically form an important tripod of sorts. So you'll definitely want to attend that one.
All right. Thank you all very much and have a good day. See you later. Bye-bye.
Thank you, everybody.